Hello guys, welcome to 13 Universal Learning Beyond Barriers, and this is Shedro, and we're going to be looking at A-level CIE biology. Okay, so the materials are from CIE past questions. Please check other videos. We've done a lot of videos and series in other topics. Watch them, share them, like them. Okay, and other subjects too. We're working on that. Now, this is starting a new series, Plan Transport Series 1. Let's go. Get your writing pad and pen, calculator. Let's dive into this question. The movement of water through xylem. Okay. The movement of water through xylem vessel is affected by external factors. A decrease in which external factors would result in increase in water movement. Okay. Increase in water movement. Guys, watch. These are the four factors. Okay. One is humidity, light intensity, that's the atmospheric humidity, light intensity, external temperature, wind velocity or wind speed. Okay, now look at this, guys. Remember, when atmospheric humidity decrease, was this is saying a decrease in which factor? All right, will cause increase. All right, a decrease in which factor? Now, of course, humidity is indirectly proportional to transpiration rate. Okay, of course, transpiration rate, and of course, external temperature is, this is the first I wanted to know, is that proportional to rate of transpiration, rate of T, RT. RT value is rate of transpiration. Okay, so I'm just going to give you the relationship. What relationship? Okay, this is directly proportional wind speed or wind velocity to RT value. Now don't forget this, it's always like this, it's always be like this. Okay, especially from the beginning. All right, not all the time across a graph, because graphs have different sections and slopes and all that. But from the beginning, look at this, guys. So you see that the only one that has inverse relationship here is atmospheric humidity, and that should be the answer. That a decrease in this causes an increase in this, right? So I'm going to tell you why. Okay, so if atmospheric pressure, right, decreasing, atmospheric humidity, just want to show you something. Let's assume we have something like this. Do you remember this? Do you remember this? Just want to show you this. Okay. What is this? Just want to show you. Um, but you can try the question if you want to try it. Try the question. Just want to sketch something for you. Watch this. Now, of course, we have all these other, spongy mesosphere inside the leaf. Let's assume this is leaf. I'm just drawing. This one is sorry for diagram. This is lower epidermis. Okay, all right. So we have of course all the spongy, right? Just not gonna go deep into that. Okay, all right. So this is inside of the leaf, right? Okay, so watch this, guys. um See, this is the atmosphere. Okay, atmosphere. So if the humidity is level of saturation of the air with water vapor. So there's always water vapor here. Okay, water vapor is always here. They evaporate. Okay, sorry, water vapor evaporate from the cell wall of mesophyll into the airspace, and then they can diffuse then through the stomata. Right, this is going on. Okay, okay, all right. So this is guard cell. That's guard cell. That's guard cell. Okay, so see that. So you see, if the humidity is low, that means the vapor outside in atmosphere is quite low compared to the vapor inside, and that increases water potential gradient between this air here and air here. So the water potential gradient will increase. The water potential gradient or diffusion gradient becomes steeper, and therefore the rate of transpiration increases. Okay, but if it's external temperature, see, once it increases, rate of transpiration will increase. Why? Because when temperature increases, there will be more evaporation. All right, so more water vapor will be formed here, so that increases water potential gradient. So water goes out. So as temperature increases, of course the rate of transpiration will increase. Look at wind speed. When it increases, rate of transpiration will increase. Why? Because when wind speed increases, all right, you see that the air layer above, okay, close to the stomata, will be replaced, that humid air layer will be replaced by dry air. So if you replace humid air layer with dry air, you have increased the water potential gradient. Is that okay? And then it's going to increase rate of transpiration. Okay, so that's why they have direct proportionality. For light intensity, once light, all right, is shine, once light falls on the leaf, the stomata will open so that CO2 can diffuse in for photosynthesis. So that means more light intensity, more rate of transpiration. Okay, the only one that has negative relationship is A. Okay, so that's question. That's the answer. Please, you can tell us what you think. Chat with us. Look at this. The diagram shows the water potential in some parts of plant cells and environment. Okay. Which statement describes the movement of water between the cells and between them and the environment? Good. So look at this. Remember that water moves from less negative to more negative. Okay. So look at how water moves. Water is the least negative is cell 2. Okay. So water will always move from cell 2 to the environment. Okay, because it's less negative. Less negative means high water potential. Please know that less negative means high water potential. That means less negative water potential means less solute potential. Therefore higher water potential. So it moves from less negative to more negative. From less negative to more negative. Okay, more negative. -3 is less negative. -4 is more positive, more negative, right, to -3. So you can see that water will always move, right? So here water will move from environment into the cell, from less negative to more. So you get water move from environment into the cell too. Okay, so that's how it's going to happen. So let's look at, sorry for the background noise. A says, the diagram shows the water potential in some plants. Okay, so which statement describes the movement of water between these cells and between them and the environment? Okay, it says all three cells are turgid, so no water moves. Water is going to move because they have different water potentials. Anytime there's water potential gradient, water is going to move. Okay, they don't have the same water potential. This is -7 kilopascal, -3 kilo, so they don't. So, all right, and of course, you can't say they're turgid, right? So water is moving, right? Water moves. B says water moves from cell 1, cell 3, and environment into cell 2. Water moves from cell 1, cell 3, and environment into cell 2. That's wrong, because water does not move, all right, from low concentration, low water potential to high. Cell 2 has high water potential because it has less negative value. Okay, less negative value, so that means high water potential. That's how it works. So B is not correct. C says water moves from cell 3 to the environment and from the environment to cell 1. From cell 3, let's go from cell 3 to the environment, from cell 3 to environment. Yeah, I think this is correct, guys. Yeah, do you know why water moves? Cell 3 has higher water potential because it's less negative. Yes, that's what it should be. Okay, yes. Okay, all right. So water moves from cell 3 to the environment. Good. What is it? And then from from the environment to cell 1, From environment to cell 1. Where's cell 1? From environment to cell 1. Yes, because it's moving from less water potential. Alright, this is less negative, which is high water potential. Less negative, high water potential. More negative, low water potential. So water moves from less negative to more negative. Less negative to more negative. This C is correct. Okay. D says water moves from the environment into cell. No, water can move from here into this. It can move from environment into this, because moving from less negative to more negative. But it can move from more negative to less negative. It can move from more negative to less. So D is wrong. D is wrong. Okay. So C is correct answer. Sorry for the background noise. Okay, let's go to the next question. What is the main functions of a companion cell? Okay. Companion cell is a cell close to Sieve2 element of phloem, right? The companion cells provide cytoplasmic contact with contact with Sieve2 for loading. Yeah, it helps for loading of sucrose, movement of sucrose from the source. The source is where it is made. Where it is made is mesophyll cell or mesophyll cells, right? So companion cell helps in loading because companion cells have transport proteins required. Why? Because it has nucleus. Okay. Sieve2 doesn't have nucleus. Sieve2 does not have nucleus. Sieve2, let's assume that this is Sieve2, right? I'm just sketch this. It is Sieve2, all right? This is Sieve2. This is Sieve2. Sieve2 does not have nucleus. It has few organelles, and this is companion cell. Companion cell has nucleus, right? Yeah, it has nucleus, so it can make transport proteins needed to move substances, like it can make hydrogen ion pump and also the co-transporter protein, right? Yes. So this is the source where sucrose is made by photosynthesis. Sorry, I'm giving you a sketch. This is companion cell, this is Sieve2. So companion cell moves sucrose from here into here. Why? Because it has the transport proteins that pumps out hydrogen ion, right, out of this companion cell into this cell wall, okay, which sets up concentration gradients that allows hydrogen ions to move in with sucrose. So these transport protein for moving out hydrogen ion and for moving hydrogen ion and sucrose, all right, can only be made because of the presence of nucleus here. There's no nucleus here. So it has also rough endovascular reticulum for making the transport proteins and also for Golgi for modification. All right. So A is correct. B says providing structural support for the Sieve2. It doesn't provide structural support. It's a Sieve2 seed plate. Providing the nucleus for cell division in the phloems. No, it doesn't provide it for cell. It's not the main function. It's not the main function. That's not the main function. Okay. Providing source of assembly. It's not for storage. It doesn't store it. So the main function is loading. Okay. All right. That's A. The diagram shows a model which can be used to demonstrate mass flow. So see the mass flow here. Okay, I wanted to use to demonstrate that. Okay, you can pause this video and try this. Okay, good. So the diagram shows a model which can be used to demonstrate mass flow. So which description of this is correct? Look at it. They say X and Y are filled with sucrose solution of different concentration, causing water to move in or out of X and Y by osmosis. As a result of hydrostatic pressure, sucrose solution then moves through the tube T, joining X and Y. So moving through T. Sucrose is moving through T2 tube T. This should be what transport tissue should it be, guys? Which transport tissue moves sucrose? That should be phloem, right? Okay. Then now let's go to the option. What water potential in X here compared with Y? So this has, look at what they said, concentration of sucrose, concentrated sucrose solution. So it has high sucrose, okay, concentration. So that means it's going to have less water potential. This is high, low, because dilute means it's going to have low sucrose concentration, that means more water potential. Okay, so X compared to Y has lower water potential, that's more negative, because it has more solute, more sucrose, more solute, it's going to have less water potential. Okay, so A and B eliminated, C and D, let's stay in C and D. The next says directional movement of sucrose solution into, of course, sucrose is going to move from high, all right, where it is high in amount to where it is low. Okay, so it's going to be from X to Y, X to Y. So low water concentration, okay, in X compared to Y, and it's going to be from X to Y. Okay, so what do you think is the answer? C. The graph shows relationship between the loss of water vapor through stomata and an external. Alright, so please, you must get this. They say, what is the environmental factor? Which environmental factor has this relation? This relationship is a negative relationship. Okay? The first question we spend time on this. We say that temperature is directly proportional to rate of transpiration. That's rate of water loss. We said it before. Atmospheric pressure, humidity is indirectly proportional. That's negative relationship. I think I've told you our answer already, but don't forget this. And the light intensity is directly proportional to rate of transpiration. Okay. All right. Wind speed is directly proportional. Don't forget that. So that means when they increase, rate of transpiration will increase. The only one that has negative relationship is B. So that means as humidity increases, as humidity increases, loss of water will drop, it will decrease, because the water potential between the leaf and the environment will be low, less deep, so less water will go, so it decreases over time. So the answer is B. Right. So the diagram shows a longitudinal section through a transport tissue in a plant stem. Now that's it. Okay. So what are the names of the structure labeled X and the tissue in which it is found? Okay. So look at this. Now this shows sieve plates. Sieve plates. This looks like sieve plates that allows movement of material sucrose from one sieve tube element to the next, and it is only found in xylem. So it's found in sieve tube. Okay. So it's not found in sieve tube. So that's xylem. Okay. So that's A. 7 says, in which combination of environmental factors conditions are the stomata of a plant most likely to close? Sorry for the background music, but enjoy the music. Okay. All right. So which one combinations of environmental conditions are the stomata of a plant most likely to close? Now, stomata of plant it closes only when there's high rate of transpiration. When excessive amount of water is being lost, all right, the plant is going to become stressed, and it will release the hormone called abscisic acid. That is the hormone we call ABA. This ABA will, all right, trigger cell signaling events that will lead to the closure. So the stomata closes when there is less water in the environment, or when there is excessive loss of water. Okay, let's look at the conditions that lead to excessive loss of water. Atmospheric humidity. If it is high, there will be less water loss because it has inverse relationship with the rate of transpiration. So that means that if atmospheric humidity increases, the water potential between the environment and the leaf will become less water loss. So A and B cannot cause this to close. So come to C and D. It's a soil water potential. See, soil water potential. Now, if the soil water potential is high, it doesn't have to close because it's taking a lot of water. But if it is low, this seems to be like a desert environment. So in desert environment, the stomata most likely close because you have less water in the soil. Okay, so it's going to be high, it's going to be low. The soil water will be low to cause stomata to close. So wind speed must be high. Why? Because high wind speed means that there's high rate of transpiration. So more water lost, the wind speed increases, the water concentration gradient of water potential between the leaf and the atmosphere becomes steeper. Okay, and then that will cause more water to be lost by transpiration. So water will be lost more here. There's less water in the environment, water will be lost more here. So what the plant does is to close its stomata. This is an early environment that causes the plant to close its stomata to prevent loss of water. Okay, so so this answer is wrong, as you will see. Okay, see it's right answer. A water potential gradient causes water to move through xylem. So which process is mainly responsible for this water potential gradient? All right, so what creates water potential gradient is transpiration. Okay, so water only is transported in xylem. Watch, in xylem, if this is xylem tube. Okay, xylem vessel, this is the root R, this is the leaf. Okay, so water moves from the root to the leaf. Why? Because of water potential gradient. So that means that the leaf has low water potential, the root has high water potential. Now what creates low water potential in the leaf? That's transpiration, because in the leaf water is constantly being lost by transpiration, and that creates low water potential in the leaf. Okay, causing more water to be transported, because water can only be transported down potential gradient, so moving from high to low. So it's transpiration. All right, which combination of features is characteristic of phloem sieve tubes? Yep. Now in the phloem sieve tube, try this question. Yeah, the phloem sieve tube transport sucrose, so the sodium concentration of the cell content will be high because they carry sucrose. Okay, and of course they are not lignified. Lignification is absent, so it's A. All right, look at the next question there. Okay, that's the end of this series. Thank you for staying. Okay, please, I want to know what you're thinking about. What are your questions? Subscribe to our video, share it. We're here for you. Thank you. See you next episode. Bye.